Welcome to Kenton's videos. Enjoy the video.
You have both equations ready. Now reduce clutter and align terms so like variables line up. First, decide method. Substitution if one variable is isolated, elimination if coefficients match or can be scaled. Once chosen, isolate a variable or multiply one equation to create opposites. This gives you a single variable equation to solve. Make sure to simplify coefficients and clear fractions early, because messy arithmetic multiplies mistakes. Proceed immediately to the algebraic manipulation. Once the elimination setup is complete, multiply rows so one variable cancels when you add or subtract the equations. Carefully perform the addition or subtraction. Track signs and combine like terms to avoid sign errors. After elimination, you'll have a one-variable linear equation. Solve it and substitute that value back into a simpler original equation to find the second variable. Make sure to carry through any multiplication factors so your substituted value matches the scaled equation. Now substitute both variable values into each original equation to confirm they satisfy both. This is how you prove the intersection point is correct. If one equation fails, retrace steps. Check for sign errors, dropped factors, or miscopied fractions, because small arithmetic slips are the most common fault. If both fail consistently, consider geometric cases. Parallel lines mean no intersection. Identical equations mean infinite intersections, and report the correct conclusion.
Thanks for watching. Consider subscribing if we helped you.